your disk scheduler, or what this is also called as your lift, your lift algorithm as well. Okay, so this your disk scheduler, this is a default algorithm in most Linux distribution. It attempts to distribute all I/O bandwidth evenly among all processes requesting I/O, and it is idle for most. Okay, what this means is, I want to write into my disk, right? And when you write, so who is the guy who decides who will write and who will read? It is a device driver. Okay, so device driver has a queue. Okay, and device driver has a queue in which it piles up all your requests. So reading from this place and that way, and this device driver behaves like your elevator. Okay, it's also called like sometimes elevator algorithm. So it's like this. Imagine you have some people in different floors, and when somebody press in the second floor and probably in the fourth floor, will you go to the fourth floor and then come down to the second floor? How do you want to organize this? Okay, so this is something which is taken care by the disk scheduler, and many algorithms have come to support various kind of algorithms for disk scheduling. And you also have some hardware. See, you know that there are two types of hardware, right? Two types of disk adapters, SATA and SAS. Okay, why SAS is better? SAS has got some more ASICs, application specific ICs, who can handle your the dispatch queue in a better way. Okay, compared to SATA, which kind of does not have that. So because it has the SAS as ASICs, you pay a little more to handle this out. So this is about your disk scheduling. So we don't do anything much here except that based on your application need, like Red Hat releases a set of device drivers for that particular disk, or your vendor can. So you can ask your vendor if there are any specific algorithms which are there. But that's something which will have to come from the vendor side, and based on that we can change the disk scheduler to ideally appropriately handle. Maybe for a database running disk, I may use a different elevator algorithm. If only a web app, then I may use a different one. Okay, so people have designed algorithms that way. Okay, so NOOP algorithm attempts to use as little CPU as possible. It acts as a basic FIFO queue, expecting the hardware controller to handle the performance operations of the request. Okay, so this is one kind of a scheduler which we know of. Okay, the deadline. Okay, this scheduling algorithm places IO request in a priority queue, so each is guaranteed to be run within a certain amount of time. It is often used in real time. So as I was saying, right, different schedulers are used for different purposes. Okay. Then network tuning. Okay, so what are that parameters that we can, and as I told you, the most tuned subsystem is your network. Okay, because this is where today the whole world relies on, right? So ensure that the network card matches router and switch configuration. So that basically means if your network card is 1000 gig, please don't attach it to a 100 gig switch. Okay, so that normally doesn't happen there. Modify how your subnets are organized. Okay, now when I say how these subnets are organized means, imagine you have offices in Delhi, Mumbai, or Bangalore, Mumbai, and Chennai. Okay, if I don't want a packet which is in Bangalore and that data which is supposed to be located in Bangalore only traveling all the way to Mumbai or Chennai to get that particular thing. So to avoid this, we create what are called subnets. So subnets help you to ensure your network chat is within your own circle, but if it requires, it can go out. So primarily it should be within your own network. It should not go out unless and otherwise required. Okay. So use fast network cards, of course. So today we have 10 gig, we have 40 gig, and 100 gig is also on the way. So I think I'm not sure where we're going to use many of these things, but that's also on the way. And yeah, the other thing which you can change is the buffer sizes. Okay, the send and receive buffer sizes in your etc. Okay, let me check that. etc sysctl. Okay, it is kind of not set in this, so I will have to check on the. Okay, so okay, so this is your okay. This is what you would set your write buffer, and this is your read buffer. Sometimes you can also set a minimum, a maximum, and sorry, initial, a minimum, and a max. You can also set it in this format. Okay, so these are basically the two parameters that you will set for your thing. So what you need to remember is understand here, every socket will take so now if you're setting 12 MB per socket, then what happens is every connection will take approximately that much. So there are 1,000 connections. It will take up to 1.2 GB and things like that. Okay, so you need to understand that. So but beyond this, we don't have any other parameter that we can control of which greatly impacts our performance. And the other thing is TCP slow start and things like that, but which is only getting, it's only just about getting the popularity. We are still not in the way where we say that we can change those parameters. Okay. Okay, so yeah, file opening, I think we generally do it for any kind of systems. Today your you limit, okay, now it says unlimited, so otherwise we can change these parameters. So because earlier it was all fixed. Okay, so we of course are going to allow much more than what is allowed as a, so typically it was only 1024. Okay, so now of course we know there are thousands of connections and there are many files that we may open. Yeah, we really don't do this TCP, FinNet and things like that. Okay. Okay, so all shows, so you know that these are established, listen, established. You have time wait 1, then time wait 2, then act. So these are the general wait states. To whatever I worked, we have probably not changed this because we do not know how applications behave after you change these kind of states. So it is ideally better not to do it. Leave things as it is. Okay, so the only change which I would recommend from my experience is changing the buffer size. That definitely impacts the way applications perform, but make sure you have that enough memory to handle the simultaneous. Okay. Okay. So TCP buffers, that's what we would see. And I talked about the TCP. It's actually basically the congestion control. TCP congestion control. It is all about. Okay. So TCP star, you can probably, but it may not work in every, because everybody is not tuned for TCP slow start change. Okay, so that still continues to be in the way. But Google is one big company I know who is trying to push that stuff. Okay, so yeah, how do you benchmark? What is a request? How do you benchmark a request? Now, benchmarking we don't benchmark a web server actually. We benchmark our applications with your Apache web server. That's what we do as a part of our load testing. Okay, so that is number of requests that can be served per second. Latency response time in milliseconds for each connection, and throughput in bytes. Okay, now this is what we want to know. So first thing is number of simultaneous connections that it can handle. Okay, so that is very simple. How do we know that? See, now at this moment, if you see, okay, so at this moment, now if you see, so many processes are there. I can tune this. Okay, around 8 simultaneous connections can be made, but these can also be worker threads, which will spawn another set of worker threads. So ideally, this will be tuned not more than 256 simultaneous connections. Okay, so that parameter is something which we can change. So when I say simultaneous connections means I'm making, say, www.google.com, right? I am using my web browser to connect to a web server and the Google side. So when I open my web browser, I make 2 connections. So what this connection means, connection is SYN plus ACK plus SYN plus data. Okay, this is called a connection. This is also called as a session. This happens at the TCP layer. Okay, so this happens at your TCP layer. So TCP layer is responsible for managing a session. That is, you initiate, close, everything is responsible of your TCP. Okay, and whereas your IP provides the direction for your connection. That means to which system, to which application that must go, that is handled by your IP. So that's how the combination of TCP and IP works, right? Then response time. So what is response? To get this going, right? SYN ACK data. How much of time do you get that? In how many milliseconds? So now understand here, it is not like anymore within the process happening within CPU. Okay, the data is going out of the system, right? So all the speed will only happen in milliseconds. Okay, so how much of time it takes to establish this? So we need to test this. So what happens is you install your application. A basic test, what you do is, let's say you create a login page. IRCP. Look at IRCP. You give the username, you give the password, and press the login button. When you say press login, how long does it take for the browser to refresh and come to a state telling me you have logged in? Okay, that is a transaction. Okay, and that is a transaction. That is what you want to know in your millisecond. So this way, every application is composed of so many transactions, right? Login is one transaction. Then we may buy a ticket. That's another transaction. We may cancel your ticket. That's another transaction, right? So you may change your profile. That's another transaction. So this way, every application and In that each application, individual module needs to be tuned, timed out, in the sense to get that how much time it takes to do a particular process. This is what you do as a performance engineer earlier, and you do this as a DevOps now. So your job is to get these metrics for every transaction. Okay, so that's it. And bytes. I told you throughput, right? And I used that PMAP example and showed you. Okay, so by default, per user, right? Per user, look at how much of memory he will utilize. What does per user? If I take HTTP application is broken down into a total application memory size, RSS application memory size, and individual application memory. And the fourth is how much individual user will use for that application. If he's downloading, by default it is 1 MB, and if he starts downloading an application, that can blow up to 10 MB. Okay, so you need to look it in that way and performance tune and understand your application. Okay. Okay, so benchmarking. Okay, so yeah, as I told you, there can be various ways to tools that you're going to use. Most of the time, in an enterprise organization, you use standard tools which are provided by many of these branded companies like HP and BMC and etc. But in internet-based organizations, they don't use any of these tools. They write their own scripts to do performance. And one important aspect of a DevOps engineer is you should also be able to write scripts to do monitoring of your applications. Okay, that is one very important criteria, and profiling of your app is one activity you will do along with your engineers. Okay, so okay, so benchmarking. So I think you have a rough idea. You need to use same hardware, first record server load. I mean, these are typical way of how you start your whole work. Then carry on your static and dynamic pages. Okay, so I hope you are aware of, right? If it is HTML, JavaScript, or CSS, okay, all these are seen as static pages. Okay, they're all seen as static pages. Now, within this page, if you have an application code, today you know that all your web pages will be embedded with either a Java code or your Python or your PHP or your Ruby. This is called as your dynamic page. Okay, because why you call it dynamic page? Because this application would need to connect into your database, retrieve the data, and then display it on the web. Okay, so that's why we call it dynamic page, and this is the guy who takes the most amount of time to process. Okay, and that is why we indirectly call it as a transaction. Why it's a transaction? A transaction means because it first hits the web server. From the web server, it goes to the application, respective application. If it's Python, it goes to the Python application. Python application then connects to the database, pulls the data, and gives it back to the web server, and it displays. Okay, so that's why we call that, and the whole thing. And then another important feature is, we will do telnet. Okay. Look up. Okay, so we will do a telnet port 80. That's your web server, right? And I get disconnected. I say get I don't know whether this thing exists. I just say if index is there, index.html, and then I use a protocol HTTP 1.1. Okay. Okay. So I kind of entered, and it pulled me this page. Okay. But what I wanted to show you was not the page actually. The last line of it. It says connection closed. Okay. So if you don't want this to happen, we set a parameter called keep alive. Okay, we set a parameter called keep alive. So what does we can be set in the web server? Keep alive means please don't close my connection as once I just get my page. Keep it alive because I may be using that connection for maybe another more request. Okay, but this is also dangerous. Why? Imagine if I keep this infinite amount of time, then it will just keep consuming, right? Each connection comes, it never dies. That means it will take up all the memory, ultimately crashing your system. Okay, so you need to be cautious on what is the time that you want to set. It may be 5 minutes or so, or it can be 15 minutes. Okay, so that depends on you. Okay, so there are some tools like AB. AB is um, a web server benchmarking tool, and these are default tools. Okay, these are for raw level benchmarking. We can it's actually a basic. I mean, this cannot be used for my application profiling. Okay, so application profile, I would probably need to write my own code. There is no other way out. Okay, so by using this tool called AB, I can send the select whatever I did now. I can send like this simultaneous connections, send, get, whatever, and then pull it down. Okay, so this is a session which I'm doing. Okay, so this is syn ack and then data. That's what we saw here. Okay. Okay, so of all earlier, we had many other protocols, right? We had like we had our FTP server, our okay, sorry, it is all getting into that. We had FTP, we had NFS, you had TFTP. There are many sharing protocols. Then you have Samba. I'm sure if you may know this, right? Samba, and then we had CISF. Now, yeah, as we stand today, all this is kind of dying out. The only protocol which is being used for all of this purpose is going to be HTTP. This seems to be the standard way to share anything. Share anything. We are seeing today in all FTP servers are also dying out to share. We use a web server instead of that. Okay. So yeah, so if you had this particular, let's probably install this and let me check. Okay, so yum install. It should have. Let's check yum install. Okay, so I think it might not have it. So let me see, AB is there. Yeah, AB is installed. Okay. Yeah, this is a bit dangerous though for me to do. Colon is okay. So I'm benchmarking this directly in the internet. It's an internet. So this was not an internal website. Okay. So it concurrency. It accepted. How much did I give? Yeah, I gave 5. Yeah, it gave 5. It took so much of her time, and it completed the request without fail. Total times transferred, request per second. Okay, so and you can see how many of these connections and waiting. But understand, this is a very raw test. Okay, this is not testing the actual page. In a sense, this is because this being a bare HTML, we can do it. But if this involved a transaction which has to connect to a database and things, yeah, we would need to do a little bit different. Okay, so this is something which you can try. And AB is, I mean, AB is still a good tool. I mean, no doubt for static pages, it's really still a good tool. Okay. Okay. So what I noticed is, right, this particular set of slides, I'm not going to do it here. It should have come into the virtualization, but accidentally it seems to have come. So the next class is going to be on complete virtualization, which includes Docker. So I'm going to skip this part because it should not have come in here. Okay, this is going to the virtualization.